connection is open. Let's test it. Hi, can you hear me? So this will be the first time, so it will probably take some time.
Yes, I can hear you. What do you need help with?
What is that? How Kokoro TTS sounds? That's really interesting. Um, hey, what's your name and what can you help me with?
Hi, I'm Noti, your ultra concise AI assistant. I can help with AI dev tutorials, coding demos, and more at Kno2gether.com.
Wow. I mean, I'm definitely gonna self-host this speech-to-speech model. I'm speechless. Anyway, welcome back to yet another self-hosting multimodal large language model tutorial. And this is going to be the fun one. Of course, this is kind of a sequel of our last video where we have self-hosted Ultravox. At the end of the video, we discussed that we are going to pair it up with Kokoro TTS and gonna make it a end-to-end speech-to-speech model. And I was really fascinated with the result. At least the way it produces the voice output. I am super impressed with Kokoro TTS, especially with this Ultravox model, because this really gives so much faster inference on just a single GPU machine that I have also used in the Ultravox self-hosting tutorial, that it was really mind-blowing. In this video, I'm going to take you through 3 steps. In the first step, we are actually going to integrate the Ultravox model with TTS and just use as a simple demo. And then we are going to turn it into an WebSocket based server, which we can use it with any of this front-end client like the one that you have just seen. And then in the third part, we will try to kind of replicate the Ultravox API specifications or the way Ultravox works. More about that into the tutorial sections, and we'll try and set up a proper end-to-end speech-to-speech model which we can work with for our different AI workflow. So if you're ready, let's get to my screen and let me share you how this is all done. Welcome to the core tutorial. And what I'm going to actually do is I'm going to turn off my video recording. The reason is because I'm going to run so many things locally, and I have been seeing that Loom have been crashing and was sometime not able to record the audio when I was doing the recording in recent past. So I'm going to stop the video recording so that I have the most network bandwidth, and I'm going to take you through the step-by-step flow. So you will see me at the end of the video. So let me stop the camera and let's proceed with the tutorial. So there are actually a lot to cover in this tutorial. I'll try to finish up as quickly as possible. Before I proceed with any of the code type, let me actually quickly go into the server. Now, what I have done from the last video where we have done the Ultravox self-hosting, I actually didn't kill the server. I kept it running as I was testing a bunch of things. I'm gonna actually just close it. The reason why I kept it alive is because if you have run the Ultravox demo based on the previous tutorial, you would have seen that it took a lot of time to download the model, set up the entire things. So that's why I didn't want to kill the server and just kept it running for so that I can proceed with the TTS setup like using Kokoro. Now, if you don't know what Kokoro TTS is, that is really a powerful local text to speech solution. Why it says local? Because if you go to the Hugging Face, you will see that it is only 82 million parameter TTS model, which is really, really small model, but the efficiency of it is really, really good, as I have tested and you have probably seen at the start of the video or the demo. So that is the reason why I thought maybe because the Ultravox speech to text model was really responding very fast, as you have seen in the last video, I thought maybe why not just pair it up with the Kokoro TTS and just come up with a really speech to speech experience, right? But I had this kind of thought in mind that it might become slow or something. So that is why I wanted to test it first before I actually create this video. But as far as I've tested, it was really, really fast. It was really good. Now, let me quickly go through the code that I have created. Again, it's not a very fancy code like the last one. It's very similar to the last one. And I'm just going to quickly go through what I have done as part of the first demo. So the first one is this Ultravox Kokoro test, and this is exactly similar like the previous Ultravox app file where we have done the self-hosting part. We were loading the Ultravox zero point zero 0.04 model using the transformers. We are doing basically same thing, but the only extra thing that we have done, if you can see here, apart from loading the model and is we have defined this voice assistant interface, and we have specified few of the voices like Bella, Nicola, Michael, Emma, and George. And these are the voices that are default available within Kokoro TTS. And that's what we have actually specified here. And we have again created an init method, and in the init method, just like last time, we were loading the Ultravox model from the Hugging Face, and then we are also initializing the TTS pipeline, like the TTS library. It's a very simple library, and you can actually install the library using just pip, so you don't even have to download the model or anything. It's as simple as that. So if you go to the requirement.txt, you will see that Kokoro is available as a Python library. So you can imagine, right? So once you install this library, it is actually downloading the model as part of that, and it's just using it under the hood, which is really, really awesome. Here again, very similar to the last time, we are just keeping a default prompt, and we are creating a TTS pipeline where if you select the voice, based on the voice, it will generate the response. And then we have the process speech method, which is improved. Like in the last process speech method or process audio method, we were processing the audio input and returning the text output. But in this case, we have named it process speech. Here we are recording the speech input and generating speech output using Kokoro TTS. Again, similar like last video, we are using 16,000 sampling rate, loading the input audio using a system prompt. And if there is a text response that is generated, then what we are doing, we are loading the voice here, the same voice that is available here, and we are loading that, and then we are generating the audio based on the voice config, whatever the voice that we have selected from the UI. And again, this will also run on top of Radio UI, you will see soon. And at the end, after the audio segment is created, what we are doing, we are just combining the audio segment in a 24,000 sampling rate and just returning the text response as well as the audio segments. Basically, this create interface, which is the Gradio interface function, is basically just creating the UI for us, where we have a drop down where we can select different voice, we can specify system prompt, and there is two output area. One is the text output, one is the voice output. That's it really. Again, not a lot of code, like around 200 lines of code. And of course, I have created it using AI, so it even didn't take a lot of time once we had the Ultravox app code ready. Now what I'm gonna do is just copy this. Then I'm gonna go into the server and I'm gonna create a folder called UV speech test. And let's go inside the UV speech test. So let's go inside that, and we are going to create the file, which is Ultravox speech test. I will name it .py. And then we're gonna copy this whole thing and just press Shift Control V. That should paste the code. Again, if you are spinning up the server first time or you don't know how to spin up the server, I have used Mast Compute. So we have used that, and I have attached their link and their 50% discount code in the video description. So go ahead and find that out and maybe use their VM and test this model or use it for your production purpose, whatever suitable for you. What you additionally need to do is just copy the requirement.txt, because I am already using the existing environment. I already had all those running. So I'm just gonna activate the environment. But for you, please create an Python environment and just create this requirement.txt like this, and then just install it. Pip install -r rig.txt. I have done it. I don't need to run it, but for so as you can see, as I've just run it, all the requirement is satisfied. That means I've already installed all of this module. Now let's give it a quick test. What I'm gonna do is, so let me actually first delete this file which we created by mistake. So what we are gonna do is just run Python and this file Ultravox test. This should start a Gradio based UI application that we should be able to test. Again, if you're running it for the first time, what will happen is it will download all those model files and everything, which will take some time. But for me, because I have already downloaded the models and everything, it just quickly loaded the files and I have my radio app ready. So all I'm going to do is just copy that, come back here and go to the radio live application. And there you go. This is how it looks like, the interface. What we are going to do is we are going to use one of the model there. And I'm just going to ask the same questions like we have been testing previously. Hey, what is the capital of France? And then I will hit process speech. For the first time, it will take some time because the model have just loaded, but still it was really, really fast. As you can see, the answer was there, the text response, and then we can play the voice response. That really, the TTS response is really, really good, as I can tell you, especially given that it's a very small model, the response is really, really good. I wouldn't able to tell whether it's a premium model like 11 Labs or it's just a local model. Let's test another one. So let's just say, how long is the Eiffel Tower in the city of Paris? Again, this is creating a long response. I wouldn't mind. So let me select another voice, maybe a male voice, and let's just ask another question. How many people approximately stay in London or live in London? Let's hit that. This time we are using a male voice. Let's see how is the response comes up. Yep, that looks good. So as you can see, this is all working. But then this project actually literally gave me the idea that if this is all working, why don't we just create a voice to voice application where we don't have to click process speech every time and play the speech, right? It should be automatic as a voice communication. But that was really challenging, of course, because there's a lot of things that you need to take care of different voice modulations, and you have to manage a kind of a WSS server or WebSocket server and everything. But I think I have been able to create this script, but this particular script is a bit complex. There is a bit more thing that is running on here, but again, we'll try and show you how that is all working. Because it's a speech-to-speech application that we are building, we need to have some kind of voice activity detector to detect when the speech is stopped or something like that. That's why we are using Celero VAD. But I think at the end I have been using some button as well to control it, because I found that Celero VAD was not working really good on 16,000 sampling rate. I'll come to that later when we will test it, and you will see. Again, in the process audio, basically we are doing very simple, that we are getting the audio chunks, merging the audio chunks, and then basically processing it through. Again, we are using different voices, as you can see here. Then we have very similar to the previous script, we have the TTS pipeline, which will take the voice input, like from the UI, we can select the voice and it will actually use the voice to create the output. Because this is a WebSocket server, we have added a CORS middleware. Of course, we have allowed star here, but in a real life production scenario, you definitely want to have CORS filter for a security purpose, where you want to allow the request to the API from specific domain, like from your production application domain or something, for added security. I added some HTML content here just to check if the Ultravox or the speech-to-speech server is available or not, just by hitting the root path. So there are a bunch of root that I have created. The root path is just going to tell you whether the server is live. And then we have startup and then w/endpoint. So startup is basically starting off the models and loading the models and everything. And w/ws is the WebSocket endpoint that will be used by the client that we have created to do the communication. And here we have added the system prompt that we will be using for this particular application. This is a very simple application. We have created an assistant called Noti, and she is basically an AI assistant for our channel Kno2gether, and let's see how that response comes up. There is nothing much, as you can see. That's all it is doing. It's basically running the UVCon. We are using UVCon module to run it as an app or as an API rather than just a radio application. So that means this is just the API part. We also needed to create the front end. So for that, I created a very simple front end with just one app.js file. And in the app.js, there is just a list of voice from which we will select the voice. in the console, and we have a button which is icon button. This button will be looking like a microphone, and when you click that, it will check whether the recording is already on. If it is on, then it will stop the streaming. Otherwise, if you click it, it will start streaming. That means it will start recording and it will send the recording to the backend server over WSS. There is some animations that we have added. Of course, when the recording is on, you will see some wavy animations. That's all really. These are all some of the UI bits that I have added. When the recording is on, then the microphone box should be giving some kind of animations and all of this really. Okay, there is not again much. This is just one file. As you can see, it's not a really fascinated UI application, but this works as you will see. So first what we have to do is just again for the last time, we will copy the speech assistant server, which is this one, and we will go back to our server, just come out of this existing radio application, and we will create another one, which will name it server.py. You can name it anything really, it doesn't matter. And just to control D. So that's all ready, and we will just run server.py, and that should start up our server, hopefully without any issue. It's loading the Ultravox model and it's using CUDA. That means it's using our GPU and our application is started. As you can see, how do we confirm that the application is started? Is very simple. We go to our master compute thing and we are going to just copy this, and we are just going to hit 7860, and we can see that the page has loaded. There is a header, Ultravox WebSocket server is ready. That means the server is ready and it is running. It has loaded everything. So we can do the test. So for doing the test, again, we come back here and we go inside speech with UV Kokoro. That folder that should be inside Ultravox Kokoro and then speech with UV Kokoro. So we are now inside this particular folder and we will run npm dot. That should start our UI, which is the client side application. I'm just going to minimize this. And there you go. Our simple yet effective front end is ready. And as you can see, it has able to also establish the WebSocket connection. This is from the server that the connection is open. So that means we will be able to test it. Now, last time we haven't tested this voice. So let's test with Nicola. And just allow. Hey, can you hear me? Now it has sent the voice, and because it's first time, it will take some time. I didn't actually heard any audio data. Let's try it. Can you hear me? What can you help me with?
Tools and frameworks. What do you need help with?
Let's try another model. Let's try the Nicole, and let's say, and where I can get all the tutorials, resources, and everything.
Head over to Kno2gether.com for all tutorials, resources, and more.
This voice is really crazy. I think there will be a lot of misuse of this voice. I'm telling you. Anyway, let's use Emma, which is an UK female voice. Let's see how the accent looks like.
I'm Noti, your AI assistant. I have knowledge on AI dev tutorials, practical coding demos, and latest AI tools and frameworks.
Where can I find all the resources for all the demos and everything that you produce?
Head over to Kno2gether.com for all my demos, tutorials, and resources.
So as you can see, this is really, really fast. And I think this is what and real speech to speech model should work. And the latency is even within a second, as I have seen. And that actually gave me the idea to actually create the Ultravox API specific endpoint. When you use the Ultravox API, what happens is you first make a call to /API/call endpoint. And when you make the first API call, it give you the join URL, which is nothing but a WebSocket URL. And over the WebSocket, your client application will basically do the communication. So what I have done as a next step is I have converted this speech assistant into the speech server, and using the same particular approach like the first calling API calls, and then it sends back the WSS URL, and then using the WSS URL, our client join that particular call, and then it is able to communicate. But spoiler alert, this code is still not working. The reason is because there has been a lot of issues when creating this agent or creating this particular assistant, because we had to infuse memory, we had to ensure our VAD parameters are all good so that it can detect when the speech input is finished, and so that it can process. It needs to also process the speech of different sample size. So there is a lot of thing going on, and then there is a state management happening as well. For example, the agent will be in listening state, and then it will go into thinking state, then it will do a speech state. So there are different state that is being managed there. So there is a lot happening in this server. And when I did a quick test, what was happening is it was actually getting stuck into the listening state. And I think the reason is because the VAD, or the voice activity detector, is not properly set up yet. So I will do some more work on this particular script, but to be fair, I have not been producing anything specific, especially for the member section. So I will probably add the improved version of this particular server to the member section only video. But as a regular member, you will have access to the script, the one that I've already created. So please maybe just download the script and try to improve upon it and see if you can make it working. That will be probably a task for you, on which you can update me in the comments of this video. Now, let me quickly show you how much we have been able to progress with this. But again, this needs a lot of refinement, because we are actually making a real-time server API specification, and that needs to be handling a lot more thing than just doing a speech-to-speech output, isn't it? So again, just like the last one, we will just do speech service.py, and we are going to paste this code, and we are going to run the speech service.py. That should start our server up. It should load the models and everything. Let's just see. This is all loaded again on 7860 port. So what we will do, we will close this, but we will use the demo that we used in our Ultravox demo, basically, not the one that we have created for this one, so that we are able to test a proper use case. So if you remember, or if you have seen the previous Ultravox demo, we have actually created an assistant for Dr. Donut's shop's drive away. So we are going to use that. Not going to go through this Ultravox sample client code in details. The reason is because I've already covered this in much detail in this particular video, which is where I have explored the Ultravox demo. So please go ahead and check that if you need to know how this is working. All I'm going to do is just quickly load a Conda environment. This is just a client. We already have this API running, which is similar to the Ultravox hosted version. So let's just load the environment, and I have forgot which environment that we created for this. Oh, I think I remember, this is the UV app, so we don't need a Conda environment. So we can just do like UV run, and then run web underscore app.py. This should actually start our front end. So we go to the front end, and then we hit this button. We actually don't need an Ultravox API key because we are not using Ultravox API. So we'll just set some dummy key. But because the client code has already been expecting an Ultravox API key, that's what I think it is asking. Oh, one more thing that I had to change to test was, earlier it was using the Ultravox API, like the API endpoint. So we had to change that, of course, because we want to test it with our own model, a self-hosted one. So that is where I have specified here the IP and the port where our server is running, and it's going to call the API calls, which is exactly similar to how the Ultravox demo was working. Now I'm going to just run it again and just refresh this and just click this, go to the server. It's loading the model. Then it has loaded everything.
Welcome to Dr. Donut. How can I help you today?
Hey, can you hear me?
It sounds like you've got everything loaded into your vehicle. What can I get started for you today at
I
Dr.
want to put
Donut?
an order of.
Can you please tell me what kind of item from our menu you're interested in? Do you want a donut
Okay,
or a
enough of this.
drink?
So let's just close it. So that's what I was saying, that it is able to detect the speech and voice, but then it was not able to process it properly. So what was happening, and as I have found, is it was continuously receiving some voice, and I believe this is probably some kind of noise from the background, and it is processing that. So what we have to do essentially to make this particular code work is to somehow filter out the noises and only process based on the voice. And that's what I'm going to work again as a next step, and I'm going to upload the video to the member only section. So if you can join the member area, and I will actually try and upload some member specific content from now onwards. With that said, I'm going to end the video. I really hope you have had some knowledge out of this video. If yes, don't forget to give it a like and maybe share the video so that it reaches out to the wider audience who need this kind of knowledge. And again, don't forget to click the link below and get all the code for absolutely free and join the community. And I'll hope to see you on to the next one. Till then, take care and bye.